Tammy asked a fantastic question I want you all to hear. I don't mean to embarrass you, Tammy. It was a great question. Her question was, so we're going to do an exponential, right? And unfortunately, I said, yeah. And I'm like, oh, stop. Take a look at your data first. Graph the data. See how it's shaped. And then decide would an exponential model make sense. I mean, pedagogically and educationally speaking, we're talking about exponential models, so you would probably default to an exponential model, yes? But now imagine you're me sitting with Captain Porter at the Bend PD, and he goes, here's my data. How do I predict what's going to happen in 2020? Okay, I had a guess it was going to be exponential, but I had to graph the data, look at it, and say, okay, it could be this, or maybe this. So that's your question. It goes beyond this classroom. It's which model should we use? To which I answer, look at the data and decide. Yeah? So that's what I'm thinking we're going to do. Can I mute that? Is that okay? We got the data in our TIs? So let's take a look at it. Now I put my data in L3 and L4. It's like I've lost L1 and L2 for some reason. That's totally fine. Oh no, there it is. It's up higher. So what I'm going to do is I'm just going to switch my plot to L3 and L4. You guys probably put it in L1 and L2, didn't you? I'm guessing. So you guys just press zoom 9 and all as well. I want to leave the other data in there too. Okay, so I'm going to go zoom 9. That's what my data looks like. Do yours just like that as well? Zoom 9. Zoom 9 and see Michelle, yeah?
No, did we not take out 16, which was...
We did. I did too. I did too. Yeah, this is 15.1 right here. Now, you can, if you left 16.0 in, you would see one more dot. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you put in 16, it would be a little box right there. It won't be a problem until you run the regression. That's when the TL will get pissed at you. But I haven't done that yet. I haven't done the regression yet. I'm about to do it. I'm about to do it. But I want to make sure we see this shape. Because Tammy's question is, I don't think you realize the gravity of the question you asked, Tammy. I mean, you don't want to blindly fit an exponential model unless you look at the data and go, oh my God, it looks exponential. Oh my God, it looks exponential, doesn't it? Yeah? No, it doesn't? You don't know. Does it look like, hang on. May I, if I may? Hang on. I'm going to turn a second plot on if it's okay with you guys. Plot 2, I'm going to turn the coin plot back on. The one we just looked at. Huh? Okay, same window. See, I put plus signs for the coins. You see them in there? See them in there? Here's the coin data. Here's the card data. Do they look similar? They look similar? Ish. Tell me how they're similar.
They're curved.
Okay, they're curved. Are they gonna go back up?
No.
Why? How dare you? Why? Why wouldn't they go back up? Give me a good argument as to why they won't go back up. I love the fact you said that. Good, Joey, good! Once they're out, they're out. The only way to get them back in is to let them start flipping again once we've told them to stop. Thank you. Once they're gone, they're gone. They can't come back. So the only way you're going to go, the only way you could possibly go is horizontally. You can't go back up. Going back up would imply we're putting folks back into the mix and changing the initial amount. And that's not, FYI, just as again, what you guys say is so wonderful. What you're describing, if you weren't allowed stuff to go back in, is called an annuity. Okay? When you guys start saving for whatever, for retirement, for education, for whatever, what you want to get yourself in the habit of doing is saving a little bit at fixed intervals. Direct deposit is going to do this. We have the option. That's an annuity. That's changing the initial amount on a regular basis. One thing you could do, you've often heard the story that if you put $1 in the stock market in 1900, it'd be worth something like $2,500 today. You know, if you put $1 in the stock, just by interest rates. If you look at the interest rates over time, I've got a quiz coming about this, FYI, just so you know. It's an important exponential function for you guys to deal with because it involves money, and it involves saving, and it involves why you should save and things like that. But what's better than putting $1 in an account in 1900? Putting $2 in an account, say, every month, starting in 1900. You're going to have a hell of a lot more money because that percentage is getting applied to a larger and larger amount as time goes on. It's going to grow like this versus like this. But that's not happening here. This is not an annuity because we're starting with a fixed amount and then removing from that amount. Thank you. Very, very nice. Please!
Her calculator has it going the opposite way.
Interesting. May I see? That's freaking, oh, that's actually your curve. And that is a quadratic curve, which means it's, you read it at quad reg instead of an x reg, and that's okay. Nope, that's my weight curve. You have that left over from when we did the quiz last week. We'll overwrite that in a second, don't you worry. We'll take care of that momentarily. That would be an annuity curve. We're gonna clear that out and deal with it momentarily. Joanne.
No, I think I got it.
Oh, okay. If you're not sure, so again, friends, it's similar to the coin flip curve, yes? Notice how they're both kind of coming into this area up here. Does that make sense? Why would that make sense, do you think? How many of you flipped coins?
280.
289. How many drew cards? 218. Almost the same number-ish on the grand scheme of things from 0. And what's happening to it as we go down here? They're starting to head towards?
0.
Are they ever going to get there? Theoretically, no. Good. Even though we did. Kelly, eventually, he pulled the diamond. But theoretically speaking, you could keep pulling forever. It just gets too hard to do that forever. Is there a difference in the curves? There seems to be, what it looks like to me anyway, is that they start kind of the same, they gap, and then they rejoin. Huh. Let's explore that. Let's explore. I'm going to turn the coin flip curve back off. That was plot 2. And only focus on my card curve for right now. Since I think we've agreed it looks exponential, yes? So Tammy, thank you for that extraordinarily wonderful comment. Or question, I guess. Should we do an exponential? I think we now know we should. The question is, can we learn something from the curve? Let's find out. Let's find out. Everybody, expreg this. So this will take care of that curve for you. Carrie, you'll just do the correct curve now. Calc. I'm going to have to put a couple extra variables in mine because my data is not in L1 and L2. You guys don't have to do this. I'm not going to press go until you guys tell me to. Okay, that was one person's. Okay. Go. 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 All right, here we go. Ah. Okay. 211. That's not what you guys got?
That's not what I got. I got 218.
Yeah.
I got 218.
Same B value?
I think one of your dots is
Your
off.
graph, mine doesn't.
Oh, hang on. Hang on a second. Let me look. Let me check my data. Hang on. 218. Yeah, L3, L4.
The 3 and 4.
Is it 3 and 4 that's wrong? Is this wrong? Check my date. 218. 142.
372.
Oh, hell! I'm sorry. I screwed up. 72. I'm sorry. I had a wrong data point. I'm sorry. Please forgive me. My mistake.
Oh my god.
Here it is. There. Oh! That was it's funny. I'm such a stat dork. That didn't even bother me. I gotta change that curve. That didn't even bother. That one little guy had a hump in it, didn't it?
Yeah.
There was a hiccup in the curve, and I'm like, oh, whatever, random numbers, blah. It didn't even strike me as something was wrong because I'm so used to seeing those kinds. But that looks even smoother now. Let me run the curve again. That's the wrong curve still. Is that what you guys got?
There we go.
Okay. Thank you. That's a close one. Sweet Jesus. All right. So.
Yes, my son.
Yes, I'm here. So now cards dealing until diamonds. We got a new model. Yes. Please, Tim.
Mine it won't go. It won't put it in the
Put the Y one right after that.
Just.
Yep, right after exponential. Yep. So the new model we get is Y equals, looks like 219 times 0.68. Get your booklet out, I explain it to you. There's our new model for our coins, or excuse me, for our cards. Actually, technically speaking, it's a four-sided coin, isn't it, if you think of it? Think of a deck of cards as a four-sided coin. You can think of it that way. Or just think of it as a deck of cards. It's got 4 different things. Well, I mean, that's kind of what a deck of cards is if you look at the suits, right? Four-sided coin.
There's so many other numbers that go in.
Oh, of course! 52, 13, but if you look at the
If you're guessing
suits,
at the suits, yeah.
it's four-sided coin, yeah. So, friends, here we go. What is the 219 standing for? Roughly the amount of participants as part of the experiment. What was it actually?
218. Wow.
218. That's not bad, is it? That's not bad. That's not bad at all. Well, best fit model. Best fit, not perfect fit. That's pretty freaking close. I mean, if you think about it, that's ridiculously close. Being off by 1. So, again, we have our initial amount.
Yeah, mine's fine.
We have our initial amount right here. We have our initial amount. And then we have that beautiful 0.68, which is 68
your maintenance rate?
It's a good 68. What am I looking for?
Percent.
Percent. Thank you. It's our maintenance rate. Maintenance rate, which means we are allowing what percent through?
63%.
Roughly 68% through. Roughly, we're letting 68% go through each round. Each round, we're allowing 68% to go through each round. We're dumping, what would that be, 32%? Now, what's fun about this is, could you have thought of a model? Remember how we did this model after we did the data model, the empirical model, and then the theoretical model? Could we have come up with a theoretical model based on knowledge of a deck of cards? Now I think you can. But maybe we couldn't have half an hour ago, but I think you can now. Chloe?
What is the initial amount of what?
Of people, sorry, you came a little bit late. It's the people that started the experiment. 219 people started the experiment.
But there wasn't 208.
It's a best fit, not a perfect fit.
Okay.
Remember, the best fit lines don't exactly hit the data. They approximate it as best as possible. But if Chloe demands better fitting, let's do it. That's where the theoretical model would come in. Faith, what are you thinking?
Well, just, I mean, a coin is just 50-50.
Yes!
50%, and since there's 4 suits, it's like 1 out of 4.
Yes!
Maybe it's 75%.
Yes! Exactly. So, we'd start with 200. So, Chloe, you might like this model better. We're going to start with 218 people. Perfect. Faith, John's over here. Faith's over there. Tammy.
There wasn't 218 people, but there was 218 draws.
Exactly, but the way I want you to think of it is 218 people on a line, and they all pull a card and look at it.
Right, but I think...
No, absolutely. And again, that's why I'm glad to record all this stuff, so we have it all for posterity. So 218, the maintenance rate is 75. That means we dump 25% each round. We allow 75% to go through each round. But the model we came up with only recognized 68%. It didn't catch 75. Why? Because we were dumping too many people, and we had to do more trials to let it see more data. Actually, says perfectly 75. So in other words, the theoretical would be 0.75 to the x, wouldn't it? Because we're losing 25%. Why are we losing 25% each round? Because assuming, oh, I like that word chance back there, it makes me happy. We're assuming that we're all drawing randomly from a deck of cards. Out of every 4 people, one should get diamonds, one should get spades, one should get clubs, and one should get hearts. Thank you. Now, I don't mean that to imply that these 4 people are each going to get one and one different thing. But on average, over time, we're going to lose a quarter each time with the diamonds. Which means we're going to leave behind 75%. Go ahead and graph that. Graph that alongside. Graph that alongside. Let's put it over here, I guess. So the maintenance rate is 68% by our graph, 75% by theory. Let's see how our theoretical, we'll call this the Chloe graph, 218 times 0.75 to the x. Let's see how it looks. Okay, there's data. That's empirical. Here comes theoretical. Well, define huge. It's off by a significant percentage in the middle. Remember what I said? We were dumping too many people? This is the pure 75%. It's going to catch back up at the end. But the idea is we didn't do enough trials to see it. That's all. We didn't do enough trials to see it. Fair enough? Yes, good. Fair, good, maybe-ish. Now, let's collect the rock, paper, scissors data set. I got to think about this now.
I wanted to follow along with that, but if I
Oh!
see what it's saying here and it's not doing it.
Sure it is. So you did exponential array, and then you put a y1 out like that. There it is. There it is. You got to follow it exactly. That's okay. Now you know. And here's the thing. Resist the urge. Tammy, this is, again, using my booklet there. Never push any button unless I tell you to push it in the manual. Honestly. Because I've got that thing so prescriptive, it's like push enter, then push enter again. Don't push it 3 times, just 2 times. I told you a story about that broker.
Push that extra.
I told you a story about the broker at my mortgage payment, didn't I?
Yeah.
You gotta pay $2,500 a month. No. But yeah, it says right here. Yes, you're pushing the enter button like 6 times. So just very prescriptive. Try to be that way. All right.